Hello guys, and welcome to Comprehensive Tutorials. In today's video we will be looking at uniform initialization, variable initialization, and member initialization. So let's just quickly go over what we did the other time and then continue. Right, so this line is a basic line that's included in every C++ program, and this line is this environment specific. You don't need to have it if you are using other editors like Visual Studio. Now these are constants that we have defined so that we can use T in place of this escape T character to denote tab, or we can just use an L to denote a new line instead of E and DL. Right. Now this is also a line that's included to make it possible for us to use the C out. So let me zoom out so we can see the general structure of the program. So this is the general structure of the program and it's quite small to see. So let me just zoom back in. So we have a class called product, and this class is, let's say, for an online shipping something. So now this class is called product and it has attributes. Any object that we create under this class should have a price attribute, weight, name attribute. And then we have a public, so those ones are private, and we have a public, the public members are these constructors and methods over there. Right, so over here we have three constructors, and that's their link, and we have those constructors over here. So there's a first, second, third. Then after that we have a method called amount to compute the cost, and we have another method called confirmation to tell us whether the payment, to display a message if payment has been made. So far that's what we have done. Now in today's video we'll be looking at uniform initialization, what it is and what does it do. Right, so uniform initialization, as you can see from over here, the syntax, it's a way for us to assign attributes to objects during construction. So there are several ways of doing that. So let me just go ahead and then clear out this because we will not be using that, and then we'll go ahead and create a second object so that we can use that as an example. So we would have product, let's say shipment 2. So this is shipment 2. We've created an object, but then we have constructors, and constructors allow us to assign attributes to these objects during construction. Now the first way we looked at is, let's say, the functional way, even though I did not mention it. So let's say we are assigning the price, we are assigning the weight, which is 200, and we are assigning the name, which is, let's say, pen drive. Right, so this is a way of initializing them. This is a way of assigning attributes to the object shipment 2. Now this is what we call the functional notation, because we are using parentheses over here. Let's say we want to define a function, we just say int compute, and compute is that, you see these parentheses, they denote a function. So using these parentheses is the reason we are just calling a functional form. Now in today's video we'll be looking at uniform initialization first. So for the uniform initialization, all we have to do is to use curly brackets in place of the parentheses, and that's it. We are done. That's what the uniform initialization is. So basically it's like the functional way, but then we only use curly brackets over here. It doesn't give more functionalities, just syntax, and I feel you guys should know it because you are not just writing your program, you'll be reading other programs as well. So let's go ahead and run shipment2.amount to be sure that this works as we want. So then we run this. Let me come over here and put a new line so that we don't get any clash. So new line. Right, so we have created an object called shipment2 and assigned these attributes. Price is 100, weight is 200, and the name is pen drive, and we will be printing those ones. So let's run it, and now we have the price is 300 and the price is 300.67. Why is that so? I'm sorry about that. So I should have said shipment2.amount. So we run this, and the price is 100. Right, the price is 100 here, but we should we want to compute the cost as we did in a previous video. So I'll come over here and modify this function. So let's just say that this is amount 1. This is the amount 1 for only those, so that we can still use these constructors. But for this constructor, which takes double the price and the weight and the name, we want to have a second method called amount 2, so that we can be calling them separately. So we want to have, this is going to return a double. I think I should just copy this and just copy it, because it's basically going to be the same. So we are copying that method and we are pasting it, and note we are pasting it under the public domain, so it's still public. So we want to call this amount 2. It's not going to take any parameter. Will come over here and say that the price times 2 plus the weight times 3, and that will give us the cost. And then we want to say that name costs. So name costs, that costs, cost, not price. So cost. Right, then we'll return cost. So over here we have two objects, and because this one is accepting just one attribute, when we call it on amount 2, it would require price to compute the cost, which it will require weight to compute the cost, and then we would need a name as well. But we don't have those ones because of the setup that we have, because of what we are trying to explain. So we'll be calling those objects which have one attribute with amount 1, and then those attributes which have price, weight, and name to be amount 2. So then we run this and we should be seeing the effect. Right, so now we have the price is 300.67 for the first shipment 1, and then the second one is pen drive cost 800. I think we should have space over here, so between that, pen drive costs 800. Right, so we had, why is it 800? We had 100 and 200. 200 times 3 is 600 plus 100 times 2, 800. Right, so that was the uniform initialization. Now the next one we want to look at is the variable initialization. Now this is only useful for constructors, or is only used for objects which have one attribute. So over here, instead of passing this 300.67 in parentheses to use the functional notation, we could have cleared all of these and then just say that is equal to 300.67 as such. So more or less like a variable. So we can, the variable is like int a is equal to 8 or is equal to 8 here as such. So this is product shipment 1 is equal to that. So that's why it's called a variable form, because it's more or less like it's a variable of product, the product class. Right, so let's go ahead and run this, and we should not be getting any error. Right, so now we have the price is 300.67 and pen drive costs that. So there is no problem. So that's the uniform initialization and the variable initialization. Now I want to look at member initialization. So member initialization is a way of declaring constructors within a class. So over here what we did was we had constructor over here, product, another one over here, another one over here. Then after that we came in here and then we linked everything up to the class product. Right, but what the member initialization allows us to do is we can just declare it, we can just initialize the constructor within the class without necessarily doing it outside and then linking it later on. So what we'll be doing is we will just be declaring a constructor within the class, and that's it. So the syntax is over here, you will just have product, the name of the constructor, which is going to be the name of the class. Constructor should have the same name as the class. So we have product, and then again in parentheses the variables is going to be taken, and over here is a double, let's say double price, double weight, and then I think string name, right? So as you can already see some differences. In this format, we include the name of the variables that we want to have. Then the next major thing is that we would have a colon over here, and then after that we would have attribute. So now we have attribute is price, is the price we want to assign the p to. Then after that we can have a comma. Not that we should have it, not that we can have a comma, we should have a comma, right? Then after that we want to have the weight over here, and then we want to assign that to w. Then after that we assign the name to n. And one last thing, you include these curly brackets before the semicolon, and we are done. So I think there are some major points here. The first thing is that you have to include the name of the variables, unlike linking the linking. Then after that, very important, a colon over here, and then attribute variable, attribute variable, attribute variable, and after that you have just curly brackets, right? So that's it, and we can go ahead and comment this one out because we will not be needing it. And this is its link over here. I think we should just clear this because we would be using, well, I don't know what I should do, whether comment it out, clear it. Okay, get out, clearing here. Right, so now we just have two constructors over here, and we have their links over here, and we have a third constructor. Let me just clear this to be sure. Complete the clear. Right, so now we have a third constructor over here which uses the uniform initialization, and when we run the program there should not be any error. So we are going to run it and let's see what happens. So we have two objects. Basically is this particular object which is using that particular constructor. So let's run it and we should not be getting any error. And now we have pen drive cost 800 again as well. So that is the member initialization. Now the member initialization gives us more flexibility. It allows us to do certain things under certain circumstances. So the next thing we want to be looking at is the advantage of the member initialization. So I'd go ahead and then clear out all of these so that we can look at that. And now with this example, I will be picking it directly from the C++ website. Right, so we want to be constructing two more classes. So we just have one class here called product, but then we would be having two more classes for this example. So I'm not going to comment this out because it's not going to clash with anything. So let me just come, I don't know whether down here. Right, so that's the end of product, and I'm writing this code over here. So now we have class, and the class was called a circle, class circle, right? And then within the class circle there was an attribute called double radius, or should I just copy it and paste? We have double radius, and then I think I should go through it with you guys, right? So double radius, then after that we have a constructor to pass in the radius at the point of construction, and that constructor is going to be called a circle, of course. And then we want to have double, we are using the member initialization, so we'll just be calling everything directly. So we have double r, and then with a semicolon over there, and we want to just say that the radius that we have declared is equal to the r that we will be accepting. Then after that we have a semicolon. Then after that we want to have a method to compute the area of the circle. So basically what this class will be doing is going to take an object and then calculate its area. No, take a circle and then calculate its area. Right, so we want to have, let's say, double area, and we want to just returning, we are not passing any parameter because we will be accessing this parameter over here. So we have double area is, we are just going to return the area of a circle is pi times the radius squared, right? So let's say radius times radius. Sorry, not radius. Yeah, radius times radius is radius squared. Radius times radius times, and let's just say pi over here. And in order to use that pi, we have to define it as a constant, or we type in the value directly down there. So let's use it as a constant. So let's say pi is 3.14 something, but let's leave it this way for the sake of this example. And we want to say that that is going to be called pi. So anytime we call pi, anytime we call pi, we want it to represent this value 3.14, right? So right now we have a class to compute the area of a circle. Let's go ahead and run this and see if we have any errors. Now we have an error over here. It says that expected. Okay, so we have this over there. Let's run this. And yet we have an error. It says that, sorry about that. We run this and we have price is that and all of that. So those were these ones printing down there, right? So I think we will not be using these ones for now. So let's just go ahead and then comment them out because we don't want any clashes, right? So let's go ahead and create an object of circle and compute its area. So in order to create an object of circle, we want to use the circle keyword, and then want to say that this is circle 1, and it allows us to pass in one attribute during construction. We can even use the variable format to say that the radius is 4, right? So the radius is 4, so the area will be, so let's see out circle 1.area, right? So when we run this, it should be giving us the area. So we run this and we have circle whatever is private. Okay, so till now all of these ones are private because that's the default one. So we want to set this to public, and we have that. We tap this to make it good. Then we now run this and hopefully there should not be any error, right? So we have 50.24. You can go ahead and compute that and be sure that it's a true value. So then I think we should, right, so it has given us the area, so this particular class is working. So now the next thing we want to do is to have a class to compute the area of a cylinder, and to compute, the volume of a cylinder. And to compute the volume of a cylinder, you would need the area of base times the height. And the base is a circle. So essentially the base of the cylinder is going to be an object of the class circle. So now you can see the relationship there. So now let's see how we will go about this. So we want to create a class to compute the volume of every cylinder. So we want to name this class cylinder. And then the attributes would be just 2, because to compute for this particular class to work, we only need 2 attributes. We need the double height, and then we need a base as well. But what class is the base going to be? We want to make this base object an object of the class circle. So over here we have a class cylinder, and it has an object from the double class. The same class cylinder is having another object from the class circle. So that's the intuition over here. So if we have string name, this means that the class cylinder having an object from the string class. So this is intuitive that it should have an object from the class circle, right? Then we want to have a constructor to pass these values directly. So let's just say that the constructor is to be called cylinder, of course the same name as the class. And then what do we want to pass? We want to use the member initialization, because that's the advantage you are looking at, right? So we want to have, it's going to have double H, and then let's say double B. I would explain why we are using B we are using double instead of circle B in a bit. Then after that we have a semicolon, a colon rather, and then we want to set the height to be H, right? Then the comma, and we want to have base set to B. Then we want to have those curly brackets and then a semicolon. Right. So after this constructor, what do we want to have next? We want to have the method to compute the area. So we want to call this will be returning a double, and we want to call this, not the area. Why do I keep using area? The volume of the cylinder. Volume. And this volume is not going to accept any parameter because it will be accessing these ones directly from the class. And so we want to have a function that will just return the base times the height. So the base dot area, right? Because the base is an object of the class circle, and if it's an object, we can directly use the methods that come with the class circle. So base dot area times the height. I'll explain it in a bit, some of the details. Right, so now we have a class to compute the area, the volume of a cylinder. Right, now why did we have to use double over here instead of circle? Because you might be like, okay, so this should accept a circle variable over here. Now the reason is base is an object of class circle, and in order to make sense of this object has to have an attribute called the radius, and this radius is to be passed during construction. You must pass this attribute during the construction of an object. So this, using the the member initialization, then it allows us to do this. So then, as you might have observed, base B over here is almost similar to this particular one. So let's say that we were creating an object called base and of a circle. So an object, so over here, this is what we have. We have already, where is it? Right, over here we have ensured that the base is an object of circle, and then after that we are constructing it with this particular value over there. So we have circle base, and then we have whatever value that we pass during construction, B. So in essence, this is what we are doing. So that's why we want to come over here and then say that base B, and B, this attribute is a double as we have it over here. Right, so that's why we have a double over here instead of a circle, because this attribute is a double and it will be necessary in the construction of the object base. Right, I hope you get the intuition. Then after the full construction of that object, so we can then have dot area. If we had dot anything, if we had other methods over here, of course we can call them if we needed to. So all we had is dot area, so we come over here and return the base dot area times height. So let's come down here and then see if we can use it. So let's create an object of cylinder called cylinder1, right? And we want to have, so the first attribute that we want to pass during construction is the height. Then after that, the radius of base. So let's say that the height is going to be 5 and the radius of base is going to be 2. Right, so we have finished construction our cylinder object. Now the next thing I want to do is to use the dot operator to access the function that computes its volume. So we want to say cylinder1 dot volume, compute it for us, and after computing, we want to just print it onto the screen as, let's say, the volume of the cylinder, the volume of cylinder 1 is that. Right, and then let's have a new line over here so that we don't have any clash over there. And let's even modify this one too as well to be the area of circle 1 is that. Great. So let's run this and hopefully there should not be any error. And now we have an error. It says that cylinder is private. Oh, okay. So we want to set these members to public in order to be able to access them. Always I make this error. Okay, so I think it should be a good practice to explicitly state them first before, so that when you need to write anything, you just go under the respective one and then you write it down there. So let's run this and hopefully there should not be any error. Now we have the area of circle is 50.24 and the volume, the column of cylinder 1 is 62.8. So we need to correct that as the, where is it, the volume. Right, so you can go ahead and check to see whether our computation of the volume is right. So that was the member initialization. When you want to use objects in a class that are members of another class,